So for this deep dive, we're looking at a pretty strange mix of sources.
A very strange mix.
We're trying to bridge two completely different worlds, Carlos Castaneda's esoteric sorcery, and on the other hand, some really rigorous modern quantum physics.
Right. And our mission here, just to be super clear, is to find the conceptual parallels. We're looking at how they both model reality, but we are absolutely going to deconstruct the quantum woo that usually comes with this stuff.
Yes, ruthlessly.
Yeah.
So to start, we have to frame Castaneda's work correctly. It's not bad physics, is it?
No, not at all. You have to treat it as a phenomenological model. It's a map, but it's a map of subjective experience, not the physical universe.
So the goal of the sorcerer isn't to, bend spoons with their mind.
Exactly. The goal is a perceptual shift. Moving from what he calls looking, which is just consensus reality, to seeing, which is perceiving energy directly.
Okay, and the hook for that whole system, the piece we can really work with, is the assemblage point.
It's this idea of an intense point of light on our energy field where perception itself is assembled.
It basically gives a physical metaphor, a location, for your subjective reality.
Precisely. And sorcery then becomes the disciplined practice of intentionally shifting that point.
And by shifting it, you access these other, supposedly equally valid, separate realities.
That's the model.
Okay, compelling metaphor. But let's bring in the quantum correction immediately, because this is where everyone gets tripped up.
Right, the observer.
Yeah, people hear observer in physics, and they think it's a conscious person, a seer, like in Castaneda. Yeah. What's the real hardline distinction?
The observer in quantum mechanics is not a conscious mind. I mean, not at all. It's simply any physical interaction.
Any interaction, so yeah, like an electronic detector, a single particle.
A single photon, a stray molecule, anything that interacts with the quantum system. That's the observer. It's an event, not a person.
So the idea that our thoughts are collapsing wave functions to create the stable world we see, that's out.
That is completely out. The scientific explanation for that is a process called quantum decoherence.
Right.
Think of a perfectly still pond. That's your pure quantum state. Decoherence is like one tiny drop of rain hitting it. The perfect state is instantly shattered by that interaction with the environment.
And it snaps into a stable, classical state.
Instantly. It's the constant, rapid interaction with the environment that keeps reality looking solid, not our intention.
Okay, so if the physics is that settled, why should any serious scientist even bother with these non-classical ideas about consciousness?
Well, because of a huge documented failure on their own turf. It all comes back to the hard problem of consciousness.
Explaining qualia, the actual feeling of what it's like to be you. Why red feels like red.
And the classical materialist approach has hit a brick wall trying to explain that. The most dramatic proof of this just happened in 2023.
The big one. Neuroscientist Christoph Koch publicly conceded a 25-year-long bet he had with the philosopher David Chalmers.
He had wagered that by 2023, we'd have found the physical signature of consciousness in the brain.
And he admitted defeat. I mean, for an institution like that to surrender, that's huge. It says the old tools aren't working.
And that failure is what's opening the door to serious, high-risk quantum experiments. This is not philosophy anymore.
Koch himself is running them now, right? The xenon isotope experiments.
Yes. They're testing whether a purely quantum property, the nuclear spin of an atom, can affect how anesthesia works.
The thinking being, if something that fragile can impact consciousness, maybe consciousness itself has a quantum root.
It's a serious question now. And you see, Google has launched a full quantum neuroscience program. They are actively looking to see if quantum effects can survive in the warm, wet, noisy brain.
So this moves the whole conversation from the fringe to funded experimental physics.
It does. Which brings us to the deepest connection we found in the sources. The real takeaway here is metaphysical.
Both systems, when you take them to their logical conclusion, end up dismantling the same concept. Objective realism.
Absolutely. Castaneda does it by replacing objective reality with reality construction through perception, the assemblage point.
And quantum physics has its own version.
It does. Specifically, an interpretation called relational quantum mechanics, or RQM. A physicist named Carlo Rovelli is the main champion of this.
So how does RQM get to the same place from pure physics?
RQM says that an object's properties are only facts relative to another system that's interacting with it. The world isn't defined by what it is, but by what it is in relation to something else.
Wow. So it replaces objective reality with reality construction through interaction.
The structural parallel is perfect. In both views, you just can't separate the world from the one who observes or interacts with it. Reality isn't some solid thing you just look at.
It's an outcome. It's a relational process.
Which leaves you with one final and I think pretty provocative thought to chew on.
Go on.
If reality is fundamentally relational, if it requires an interaction to even define its facts, what does that imply about the world when nothing and no one is looking?